The following points you can see here is operating conditions and which need to be considered. So a normal and emergency shutdown, pressure and tightness testing, pre-start and startup, pre-startup and startup, manual operation as a result of automatic control system failure deactivation, alternate operation modes from original design, catalyst conditioning, catalyst regeneration, passivation, depressuring, removal of inventory from unit, and gas freeing. The next one is establishment of relieving loads shall include consideration of common modes of failure, such as electrical, instrument control systems, mechanical, human, and procedural. So another point during designing is relief rates, together with relieving temperature and composition, should be calculated by performing heat and mass balance calculations for relieving conditions. Factors are below: reflux, drum emptying or flooding, dry out of column sections causing loss or circulatory reflux, change of duty in air-cooled exchangers due to different temperature differentials, change in latent heat and boiling temperature due to increased pressure and change in composition. And the last one is initial gas flow during startup of shut-in oil wells. And methods of calculation shall be defined at an early stage at the design. Calculation is meant mechanical, mostly mechanical part need to be considered and need to be calculated during design stage. Again, continuation for design practice. Specialists in relief sizing for runaway reaction kinetics should be consulted to assist in overpressure protection analysis systems. Analyses are below, like too much reactant, wrong composition, too much catalyst or promoter, overfilling, insufficient usage for expansion, loss of agitation, loss of cooling, failure to terminate the reaction, loss of control. For internal explosion or runaway chemical reactions, if an inherently safe design is not practical, and if pressure relieving devices cannot protect against the situation, special requirements for emergency depressuring, halting reactions, or otherwise preventing controlling the situation shall be provided by safety instrumented systems. And relief devices that only protect piping systems may be set above the design rating of the piping. And for external explosion or runaway, the chemical reactions, if inherently safe design is not practical, as I mentioned here, special requirements for emergency depressurizing, halting and halting reactions and otherwise preventing controlling are the main requirements. So what causes overpressure? These causes are documented in standards, applied in standards. All types of causes need to be followed deeply, for all facilities. What are they? They are power failure. Local power failure, we call in some cases, local to equipment protected by a single pressure safety valve. Complete power system failure within a unit or entire facility. Individual substation failure affecting all electrical equipment by a single substation. Second one is cooling or reflux system failures, local unit, plant-wide partial cooling water failure shall not be assumed like exactly it's not partial cooling water failure. It's in our case is a complete cooling water failure shall be assumed if applicable under causes for overpressure. Third one is a boiler feed water failure. Then is multiple valve failures, open or closed. Inadvertent valve operation, control valve failure, or valve opening from a higher pressure source. Failure of automatic control, the issues can be covered under this cause is like potential failure of instrument systems, like including safety instrumented systems. For modern instrument systems that may rely on disturbed shared loop systems, potential for simultaneous failure of more than one control loop. Capability of a disturbed control system to introduce mean for otherwise unrelated control systems to be driven simultaneously to a dangerous position. And operation of controllers in manual mode or with alternative set points to original design basis. This was related to failure of automatic controls. Seventh is gas breakthrough, it's blow by. Gas breakthrough shall be specifically addressed as a relief case in industry. Blocked or closed outlets. Equipment failure, including pump, air-cooled exchanger fan, or compressor trips and shutdowns. Reverse flow, for example, check valve failure, and reverse flow release scenario is defined as when a feed pump or compressor to a gas liquid system stops and the high pressure gas liquid can reverse flow into the lower pressure system. If a single check valve is used on the discharge stream, full backflow shall be considered, and the settle or out pressure should be appropriately defined. Typically, a dynamic analysis of the process system is required to be performed to evaluate a settle out case. Next cause is a partial utility failure or interaction between utilities. Then is coming changes in feedstock or other process condition change. Properties of process fluids under relief conditions that are different from normal operation. And effect of a very large capacity source such as a wellhead or long pipeline. So the high pressure, low pressure interface shall be considered between a large high pressure inventory that feeds a system of smaller capacity designed for lower pressure, for example, subsea flow line or interfield pipeline feeding a topsides, production manifold and separator. In these circumstances, it may not be feasible to provide a relief system of sufficient capacity to accommodate the case in which the high pressure system is suddenly de-isolated, for example, through failure open of the main equipment shutdown valve, emergency shutdown valve. In this case, it may be necessary to provide mechanisms for safely depressurizing the upstream source to allow enough pressure prior to startup with appropriate SIS and procedural, SIS, I mean safety instrumented system and procedural controls. If SIS safety instrumented systems is used in lieu of mechanical devices, sometimes is happening. A detailed dynamic analysis should be performed to ensure that a downstream system will be protected, and given that is a delay between a high pressure switch activation and closure of the isolation valve. To be honest, this was a little bit short for like overpressure, and I think that I don't want to load you from the first time, because it's mostly theory, and to understand this process for it's technical. You have all that technical background, but it's first time for you, and if you just read this process, it's a little bit not always is understandable. And I would like to show industry example, like it was happened in our company. It's overpressure on piping. It's due to reverse flow. What happened? As hazard, I would like to mention that spurious fire and gas detection caused a production shutdown, including the water injection system. This piping is full of is used for water injection system. After the main water injection pump shut down, the high pressure water from downstream flowed back through the pumps. This resulted in the failure of the piping upstream of the pumps when it was pressured beyond its mechanical burst pressure. The incident, to be honest, fortunately, no injuries happened at that time when this overpressure explosion happened. But also not personal, also environmental injuries, environmental consequences also have not happened. But it resulted in extended outage of the water injection system with commercial consequences. You know that when we take unexpected shutdown, when we have an unexpected shutdown, it takes many approvals, many process, and as it is unexpected, some materials need to be from process point of view need to be ordered. Not always we have equipment spare materials, spare piping in our stock, and imagine when we have such a type of incidents, it take it requires quick response, and we need to solve this problem as soon as possible. But when you are looking at this picture, your first view that there was no any overpressure protection, but actually it was there was 3 types of overpressure protections: discharge emergency shutdown valve, which is taking approximately 1 minute to close; single non-return valve, like we call NRV, check valve; a minimum flow valve discharging overboard. So from this point of view, we had a protection, but there is no relief protection in the lower pressure suction system. And from barrier effectiveness, you know that we have a barrier which causes consequences, and barrier effectiveness for each type of this protection. It was for emergency and process safety, emergency shutdown valve and process safety time, the time between the signal that initiated the trip and the failure of the piping was 40 seconds. Since this is shorter than the time it's taken to close the discharge isolation valve, these valves are not effective barrier in a comprehensive system. This part, as I mentioned, even if it's like we put control measure, but it's like designed not properly. Non-return valve as a protection were identified as a safety-related devices. The maintenance regime involved inspection only, with no performance testing. Non-return valves were identified as safety-related devices, and the maintenance regime involved in inspection only, with no performance testing. And since they were in non-hazardous systems, the maintenance was deferred to allow for other safety critical maintenance, and like what was for actually what was the reason for barrier breakdown on NRV, that sometimes facilities like companies are focused on safety critical equipment, and inspecting safety critical, monitoring, like doing maintenance on safety critical equipment, but sometimes non-safety critical or business critical equipment becomes more critical, but we're skipping this, like we're saying that this is wide risk, like no high risk, and sometimes such type of explosions or leaks happening in this case when we just like underestimate equipment on site by saying that this is not safety critical. And like as an example, I can say for NRV, like fire water systems, where we're saying that this is just a ramp failure, it's not required to be like inspected or monitoring. Any maintenance job needs to be done there, but at the end we like facing such a problem. Like in this piping. So at the time of failure, some of NRVs, for this case I will talk particularly, were known to leak. Like even in this case, like we like skipped this risk on site, and NRV in water service frequently leak, and therefore can only be considered to reduce the amount of flow in the reverse direction, rather than provide a full barrier to reverse overpressure. So minimum flow rates, minimum flow valve, like at the third overpressure protection like point in our case, 3 of 4 pumps like which are currently which were located on that line had a minimum flow valve. These they were not identified as a safety critical. Again, like one of the problems what we have currently in previously and currently in our facilities, and were operated to failure. Upon a pump trip, these valves, when the measured flow rate falls and provides a path to the pressurized system, in the absence of a relief valve, these are the most critical barrier to preventing overpressure. Regarding minimum flow valves, like as I mentioned, 1 of 3 valves opened, 2 valves failed to open for unrelated different reasons. So calculations indicate that 1 valve has insufficient capacity to relieve the pressure from a substantial reverse flow. So like this barrier also like have not been protected, was not working at that time. So like you know that in this case we are doing fit for service calculations like for overall process, like why it happened, when, and what was the reason. So Maybe you know about like 8-to-8 matrix. Yeah, like this is the process used for like by process engineers in most cases, like for probability consequences of risk. It's used this matrix. So from this point of view, like the specific scenario this like described like in this case study, like at that time was discussed that this is could not be like part of fit for service, but from risk point of view, the like severity was put as like E, high risk. So as it is like water system, it's not a non-hydrocarbon system. So like in this case, in some cases, again, like if we are putting risk, we are trying to put a lower risk, even like it affects shutdown, but it's not full like platform shutdown or like facilities like terminal shutdown. It's just fire water system. That's why like we were lucky that nothing happened, but due to overpressure like incident, like we could face more dangerous, more like risky, more like harming people incidents. So this is all for part one. Like it's very short. Like as I mentioned that I think if you will read or listen this course, it will be a little bit like better for you to understand like the protection type. So next time when we will talk about the protection, you will be a little bit more familiarized for from causes point of view, from like case study point of view. This case study can be shared because this is like lessons learned what we are using for in our industry. It's not happened in our region, like I mean Azerbaijan, Georgia, Turkey, but it's it's happened within company. And when we are designing, like at the beginning, as I mentioned, like even during the design, we are estimating like what the like could be overpressure risk on site facility, and this such type of lessons learned case studies we are using for future projects, it's used and it's very helpful. We are updating our documents, BP documents, and we are using industry standards, and like we are working and making it more easier, not several documents, it's just one document with what we are using for overpressure. That's all. I will not take your time. If any questions or like anything, any documents you are interested regarding overpressure, I can share within like some limits and additional information regarding causes, like everything, like in examples, in more details. I can share our lessons learned. That's all.
Thank you for your insightful presentation, Aynura Hanım. I don't see any questions on chat, but if anyone has questions, you can unmute yourself and give it now.
Yeah, I understand that overpressure is a little bit difficult process and it's not easy to understand. I've had questions from the first time. It's a little bit difficult to understand from the beginning.
Hello everyone. Hello Aynura Hanım. It was really very great presentation and very interesting. Thank you very much.
Thank you.
If no one has questions, I actually had one about the shutdown valve.
Mm-hmm.
You said that process safety time was there 40 seconds, right?
Yes. Yes.
Then,
so like it's designed for 1 minute, but it was like 30 seconds.
so can we say that the valve wasn't designed correctly, or?
Yes. Yes. Like for this case, like we were like it was estimated that okay, emergency shutdown valve is in place, NRV is in place, and like minimum flow valves are in place, but are they designed properly or not? Like this is part of lessons learned, that it's not like always we're using equipment on site, but it's not always properly designed. And like none of protections have been like designed properly.
Oh. Okay, thank you for your answer. If no one has questions,
sorry, I have one question. First of all, thank you for your presentation, and everything was really clear. I have a question about the recordings and the slides. Will we be provided by them, or how?
yes, you will be provided.
Okay, thank you.
Thank you, Tim.
Okay, for yourself, like for you, like I think that next time it will be overpressure protection. Session will be about valves, like pressure safety valves, relief valves. But you can search in internet or something like which is interesting for you, and we can discuss like overpressure. Like today it was just introduction. But for next time, like when you will attend this session, you will have a little bit more information, like what's overpressure protection, when it's used, what type of like, what's the rupture disk, everything. It will be discussed during the session. And you will have more clear picture what is meant under protection of overpressure, what we are doing in like industry to protect from overpressure.
Yep. Like as Aynura Hanım said, we have another session in next week, and you can read some information before joining the session, and we can do an interactive session together. And this is all for today, and we thank again Aynura Hanım for this great presentation and the information she provided us. And thank you all for joining us, and see you. I think it will be Kemal Fatehzade's session next, and see you all there.
Thank you.
Thank you.